How you going, guys? Curtis from Cutting Edge Engineering. Today's job is going to be part 3 of our Hitachi cylinder rebuild. Unfortunately, we have had a delay in getting seals and parts, but they finally arrived, so we can get back onto finishing off our cylinder. So the first thing I need to do is make up the new piston. The material we're going to be making it out of is 4140. It is 200mm in diameter and 90mm thick. So the reason I'm going to be making a new piston and not repairing the old one by welding it up and machining it back to spec is because this is going to be an exchange component in our exchange fleet, and I need to warrant this component, so I can't run the risk of something going wrong, like a piece of weld material breaking out and damaging the cylinder. If this cylinder was for an owner operator or a piece of farming equipment, it is a perfectly acceptable repair to weld that up and machine it back to size. But on a component that we're taking back to an OEM standard, and for something as expensive as this, I'm not going to run the risk. Another reason why I'm not going to repair that piston is I am going to make a slight modification to our new piston to avoid this problem happening ever again. So we're going to get the material set up in the lathe. So the first thing I'm going to do, I'm going to face it so I've got a nice flat surface for the next process. Now we got that faced, I'm going to use my 90mm BPK spade drill to drill out the ID. So because I'm holding the drill in the tailstock and not the tool post, I do get a little bit of vibration just because of how slow the chuck is turning, but that's not a big issue because I am only roughing out the ID, and we're going to finish it off with the boring part. Now that I've got the ID bored to size, I need to counterbore this face to give clearance for the nut. So that's the machining done on this side. Now what I need to do is take the part out of the chuck and change the jaws so I can turn the part around and grab it from the inside. That way I can face it to length and turn down the OD. Now that I've got all that done, this is where I'm going to do the modification. So on the original piston, we do have 5 seal grooves and the stop shoulders which hold the seal in place. The 2 center shoulders are a larger diameter than the rest of the piston, so they are more likely to contact the barrel if the seals are to wear out. So I'm going to machine those 2 areas undersized, then I'm going to weld in silicon bronze. Silicon bronze being a very soft material, it doesn't pick up with steel and it doesn't create galling. If the seals are to wear out and the piston is to contact the barrel, it won't do any damage. So after that, I'll then finish machine all of the seal grooves and all of the other features. A bit more. So we're going to get this out of the lathe and go set it up for welding. So I'm going to be using silicon bronze welding wire in a 0.9 diameter. I'm going to be backing that with 100% argon. I'll run that at about 20 volts and 10 meters of wire a minute. With this series of welder, it has inbuilt settings depending on what weld process you are doing. All you need to do is tell it the wire diameter and the thickness of weld you would like, and then it sets the voltage and the wire speed as per your settings. So now that we've got that welded up, we're going to have to let it cool down before we can keep machining it. So while that's cooling down, I'm going to get onto sandblasting and cleaning the rest of our parts. So now our piston's cooled down enough, we can set it back up in the lathe. So the first thing I'm going to do is machine the OD of the piston down to the size of the larger shoulder. Now I'm going to go in with a 4mm parting tool and machine the grooves for the wear bands and the seals. So the steel has gotten quite hard in the weld zone, so I'm going to use some coolant just to keep the tool cool until I get through that hardened layer. Now that the grooves have been machined, I'm going to go through and machine down the shoulders to the right diameter. Now I'm going to finish it off using an S&MG to break all those corners, and then we'll give it a light emery. Now that we've got the piston machined, before I start reassembly, I need to get the rod set up on the rollers so I can polish the chrome. So what I use to polish chrome, it is an air polisher, and I do just use standard polishing wheels that you can get for your bench grinders. So we're not trying to remove material off the chrome, we're just trying to get rid of those blemishes caused from the many cycles it's done in its life. Now we're going to install the bushing. Unfortunately, we weren't able to get a genuine OEM part, so these are aftermarket, but they are top quality and would be the next best thing to a genuine component. So on the newer series wiper seals from most of the manufacturers, the steel band actually has a clear coat put on it, and that is to protect it from rust. Even though they are already zinced, they still put a clear coat or some form of coating on it. If you don't sand that coating off before you Loctite them into the gland, the Loctite hasn't got anything to bond to, so it generally just pops them out again. By removing the clear coat, you've keyed up the surface and it gives the Loctite something to bond to. Now that we've got all our seals put back in the gland, we're going to start refitting all the components back to the rod. So I haven't installed the seals on the piston yet, and that's because I do need to take this over to a mate's shop in order to get him to tighten up the nut using his hydraulic torque wrench. Just to avoid anything getting damaged or lost, I'll fit them once I get the rod back. So everything's fitted, I'm going to go get this nut tightened up. So now we've got the nut tightened up, we're going to finish reassembling the cylinder. So that's our cylinder reassembled. Next thing I need to do is take it out of the press, take it outside and prep it for paint. Did I come up and see this? I should get more. Oh no. Just share, and we can all get along.
Oh.
Ooh. So we've got that prepped, we've got everything covered up that we need to. Now we're going to prime it, and then I'm going to paint it with the Hitachi orange.
There we go.
Hey, where you go? Ooh.
So I've had to put 2 coats of paint on this, but it has turned out really good. There aren't any runs or any bubbles, which is usually what happens when I paint something. So we're going to let this dry for about 24 hours, and then we'll take it back into the workshop.
Is this one okay? What are you doing? Oh, sorry. He's okay. What are you guys doing? You guys okay? This one's normal. Those two are malfunctioning. What the heck? I just googled it. Apparently that's what they do when they're sunbathing. So they're not malfunctioning. They're fine.
So what I need to do now is install the new pin wiper seals on each end of the cylinder. Because this is a component in our exchange fleet, it will be stored until it is sold. So I'm going to go through and cap off all of the threaded bolt holes. I don't want any dirt and debris to get down in there and cause rusting. And I also want to stop the hornets. Here in Australia, hornets love to build nests inside holes, so we'll cap all those off. And to prevent rusting on any of the bare metal surfaces, I'm going to apply a thin layer of grease, which is just going to create a barrier from rust starting. Righto guys, so that's the rebuild on our Hitachi 470 arm cylinder complete. We've got the new barrel, made the new piston, installed genuine seals, gave it a nice fresh paint job, and it looks $1,000,000. So even though there is a lot of work in a job like this, it is still far cheaper for us to do a rebuild than it is to buy a brand new part from the OEM supplier. But our customer is pretty much getting a 100% genuine cylinder. We didn't cheap out and put aftermarket seals in there, and it is back to Hitachi specifications. So because this is an exchange component, when the customer buys this one, they will exchange it for their old damaged cylinder, and the entire process will start again. This is a great way for our customer to save money, and it is also a fantastic way to remanufacture old parts so they don't get scrapped and thrown in the bin. So that's this job completed. Thanks for watching. So what I'm going to do first is start manufacturing the new piston. What we have...
Hang on, just start again.
After I've done that, I can then machine all the seal groove. Oh, fuck me. After that, I'm going to machine all the seal groove. Oh, fuck me. Oh, for fuck's sake. And it will then... And it then does... And then it sets the weld... fuck. I use the...
Good start.
Thank you.
Whoa.
Just watching that.
Yeah. G'day.
Hello.
How you going?
Good. Self?
Pretty good.
Supervisor.
Nah, I'm videoing. And supervising, giving my opinion.
Sorry.
No, it's all good.
What are you doing? No, have you got time to tighten up my nut for me? Yeah? Cool beans, I'm on my way. Alright, love you.
That's not gonna work.
Not gonna be ideal.
Yep,
That much.
that's good.
Make sure that his thinners are not waxing loose from there. Yeah, look at look at that. I'm a painter.
Oh no. Is it still in there? Oh, yep.
Yeah, you miss out.
Greedy bugger. Hop, hop, hop. George.
I reckon it's a war sound. Oh, look over there, Karen. Majestic bin chicken.
So majestic.
So majestic.